Imagine that you are living in an apartment with limited access to the terrace. You are permitted to bring only one coaxial cable down from the terrace to your apartment. It is then that you have to consider remote switching of antennas. This is not an uncommon scenario among ham radio operators living in cities. As per Annexure 1 of National Frequency Allocation Plan 2022, very low power equipment working on 433 MHz band are exempt from licensing. That is how they are widely used for remote control of devices like lights, motors used for opening gates, security systems, home automation, and many more. Though I am living in my own house and not in an apartment, I have limitations in bringing down too many coaxial cables into the shack. That is why I am also interested in this 433 MHz remote switching unit. Unlike the infrared remotes which we usually use for television and other devices at home, signals from this can penetrate walls and reach the terrace from your shack. As usual, I gave an online search and found several options of buying 433 MHz remote switching modules with remote controls online. Just inquired with my local vendor in the city, and to my great surprise, he had a single piece for sale. He connected a power supply to it from the shop and demonstrated remote control switching on the red LED on the board. Now I have to plan how to install it and switch antennas on the terrace remotely. This is the setup I am using to test 433 MHz remote control. That is remote switching for switching antennas. I am just testing the signals from the remote control. I have not used it yet for antenna switching. This is an RTL SDR with its own UHF antenna. You can see two telescopic antennas which are for UHF. You can tune it by adjusting the length, but I have not done that. I have extended the antenna fully and I am testing. I have configured the RTL SDR to receive signals on 433 MHz, which is near the ham band. It is easy. I have installed SDR Sharp software from AirSpy in my laptop and 433.530 MHz. That's the signal which you have seen. You have seen a signal both in the waterfall above and below. That is from the remote, 433 MHz remote. Now I am going to test in other rooms. That was very near the RTL SDR. This is from the next room, and again I will test from room after that. This is room after that, and one more test, the most distant room. You can see the signal strength was decreasing as the remote was moving away. As you can see, unlike the usual infrared remotes which we use for TV, the signal has penetrated the walls in between the rooms. So I presume that I will be able to use it for my remote antenna switching also. But I have not tested from the terrace because it was raining. So I didn't want to go onto the terrace to test it. ISM in this context stands for industrial, scientific and medical. ISM bands are portions of the radio spectrum reserved for non-telecommunication applications internationally. They are typically used for short-range, low-power wireless communication in industrial, scientific and medical devices. But all of them may not be of low power. For example, microwave ovens, magnetic resonance imaging, and medical diathermy machines use significant RF power. These can disrupt radio communication using same frequency. They can also interfere with medical devices using these frequencies for communication, like cardiac pacemakers. Hence, appropriate shielding is needed for such devices. In general, if communications equipment operate on ISM bands, they must tolerate any interference generated by ISM applications. Users have no regulatory protection from ISM device operation on these bands. Other devices which may use the ISM bands are cordless phones, Bluetooth devices, near-field communication devices, garage door openers, baby monitors, and wireless computer networks. These devices are not generally considered as ISM devices. International Telecommunication Union has allocated frequencies in multiple bands for ISM applications. They are in the region of 6, 13, 26, 40, 433 and 902 MHz, as well as in the region of 2.4, 5.7, 24, 61, 122 and 244 GHz. Though some of these are worldwide, some are subject to local acceptance. Some of these frequencies are shared with amateur service and amateur satellite service. Yet others are shared with other services depending on the administration involved.